So thank you all for joining us. Exciting topic today around the emergence of AI engineers. With me, I have an amazing set of panelists. Starting from the left, Andriy, who's the co-founder CTO of Nomic, platform focused on explainable AI. Next to him is Erik, co-founder CEO of Modal Labs, serverless infrastructure for AI. Next to him is Ryan, formerly the co-founder and CTO of Code Academy and Decrypt. And next to him is Benny, founding engineer from Fireworks.ai. And then finally, last but not least, we have Matt, head of product from Unstructured Data, which helps you build pipelines to take truly unstructured data and structure it. So maybe I'll start off with the basic question of the idea of an AI engineer. So we've heard a lot of talk around this idea that software developers need to learn skill sets around prompt engineering, pushing models to production, putting together a RAG architecture, and a lot of these are new skills for software developers. I'm curious, are you guys actually seeing this in reality? Are software developers being pushed to learn these new skills, and what are you seeing?
Yes. I definitely think, I mean, like, I feel like, it's like one of these like new titles, and there's always like titles that they come and go, for a few years, like data scientist, and then there's prompt engineer, but I think there's like a real demand for these things, and that's why there's so much excitement around the LLMs. So I definitely think this is something a lot of engineers are gonna have to pick up.
Terrific. Maybe, Erik, I'm curious, like, what are the skills that people actually need to learn, and where are you seeing the biggest gaps from your standpoint at Modal? A lot of people come for different workloads related to AI.
I might be the least qualified to answer that because I'm building infrastructure, so I kind of seeing it from a very different vantage point. But my personal theory is that I think there's so much demand for ML and AI, and people are just like desperate to do that. So I think that's why there's so much excitement around LLMs. I actually think the real need is maybe more on the sort of hardcore AI side, like people who build these networks, train them, like truly understand, the structure of these networks, and how to, whatever the batch size and what GPUs to use and that kind of stuff. But that's going to take a couple of years to sort of, to expand the capacity of those types of people.
And maybe, Andriy, from your perspective, you guys released an amazing open source embedding model, and I'm sure you're seeing all sorts of developer traction, developers downloading it, trying to put together RAG architectures. What are they using? Are they relying on frameworks that are off the shelf, or do they have to build it themselves? And how do they actually go from something that they're testing to production?
Yeah, I think one of the coolest things that's happened in the past 2 years is that the barrier to entry to be able to build a system that involves like an ML component has like gone down by orders of magnitude. Like 4 or 5 years ago, what was an AI engineer? An AI engineer is somebody who knew how to spin up a Docker container containing a Triton inference server, optimize an Onyx graph, go through the whole process of being able to get inference to even to work out of some bespoke neural network that they made. And now you can just send an HTTP request and get access to state-of-the-art systems at very, very, very low cost. And one of the things that we like to think a lot about is how do we make that cost be not only as low as possible, but also spread out across anyone who wants to not just be able to, let's say, like, not be able to only have to send, let's say, HTTP requests to be able to work with their AI systems. So like when it comes to, let's say, like embedding models, right? You have a bunch of offerings in the world. You can go to a million providers, get output from an embedding model that's hosted on Together's cloud or Cohere's cloud or anywhere else. But there's lots of situations where that will never actually work, right? Because maybe you have cost requirements in your application where you could just never even be able to, like, say, use a machine learning model because it's too expensive for the thing that you're prototyping or building. And so one of the things that we're seeing out there a lot right now is a lot of people are still in the sort of the Jupyter Notebook stage of bringing AI into their business and AI into their companies. They don't have large budgets, but they still want to be able to prototype and build justification for like, hey, why should I be able to get this budget for like next quarter and 2 quarters from now to be able to build out this system? And what we're seeing right now is most companies are actually still at this stage. The companies that are actually going in and productionizing systems have actually been doing it for a while now. All these technologies aren't new. Embeddings have been around for a while. Models that generate text have been around since before ChatGPT. But the big thing right now is that the barrier to entry is so low that everyone gets the opportunity to build these systems and see what they can put together.
Very cool. Maybe I'll jump over to Matt. At Unstructured, you guys kind of have a very unique purview. You work with a lot of very, very large enterprises, including some public sector. What are you seeing in terms of the talent gap at these organizations, especially maybe juxtapose it versus Unstructured also has a huge open source presence and the types of developers that are just downloading the library and using it from that point?
Yeah, I'd say actually the level of the ability level in a lot of these big organizations is actually a lot higher than you would expect, and I think a part of that is because with the advent of the new large language models, the barrier to entry for a generalist software engineer to start interacting with NLP models is a lot lower than it used to be, and so what developers inside of these organizations are able to bring to bear that a lot of, just like an ML specialist might not, is information about the business itself. And I think if you're able to build tools like Unstructured, like LangChain, and like some of these other tools that allow you to kind of take the burden of knowing in detail every little piece of the stack and allow those developers to focus on bringing what they specialize in, knowledge of their business to bear, it really helps people get up and running and off the ground a lot faster than you'd expect. I think the biggest challenge for operating in those environments is really meeting people where they are. A lot of times from like a deployment model and like availability standpoint. And so when you're working in a lot of these places, it might be like internet disconnected. You might not have OpenAI available. You might have to consider like access controls and this sort of thing that are a barrier to entry to even getting a proof of concept off the ground. And so to the extent that tools like ours can help make that easier for these developers that know a lot about their business, it'll help move a lot of these LLM applications from prototype to production.
Yeah. Maybe switching gears a little bit, Benny and Erik, you guys both saw companies mature their AI stacks and AI capabilities. Benny, from the perspective of Facebook and Meta, and Erik from the perspective of Spotify. Can you talk to us a little bit about how does an organization evolve? Do you see a centralized AI team that's responsible for training models and running models in production, and then a lot of end users across the company that rely on that centralized platform? What you saw at Meta and or Spotify, do you think that's the way of the future, or do you think this needs to evolve as we move into the next generation of AI-powered organizations?
Maybe I can go first. I think the centralization comes a little bit unintended, not because of the structure benefits, but more because of the cost. I remember very clearly in like 16 or 17, we were still talking about models of like 20 megaflops, and that was already very big. And now you'll be laughing if some model that's open source on Hugging Face is only 20 megaflops, right? So then if there's a big cost structure associated with this, oftentimes it gets centralized onto certain teams, and that team has to figure out how to run these infrastructure efficiently. That's one of the consequences of these AI build-out that I see, which causes teams to centralize, AI infrastructure team to centralize. The counter-argument to that is actually, I think the AI product engineers are proliferating across the company. To be honest, like crafting good system prompts probably has more to do with your intuition about what the product is and how to decompose the problem rather than some built-in innate ML knowledge right now. And that prompt engineering skill, I think, will get proliferated across the company. So, for better or worse, it looks like a lot of companies going for like very spread out AI engineers, but a big AI infrastructure team that hosts most of this.
Yeah, I have a sort of similar conclusion. Maybe just kind of expand a little bit on how I think about from more of an organizational point of view. It's always sort of a tension between like decentralization and centralization in terms of like org structure and like reporting lines and also like capabilities. And I think it's always tricky when you have like these like special domain skills needed to do things. What I've sort of landed on, like for teams like this, like I used to be a CTO and running a lot of different teams. And I think what ends up working in practice is you have distributed teams, but with a centralized reporting structure And it's not ideal, but I think, on one side of the extreme would be like more like a center of excellence function where you lend out people. I think that's almost always a bad idea because now you create this like bottleneck and or like a disconnect between what actually has to get built. So I think generally it's better to have sort of a team, kind of center of excellence team, but actually like from like a day-to-day management point of view, they're embedded in the other teams and helping them build features. And for intensive purposes of like being a part of day-to-day, like rhythm, they're like basically on sort of an extended lease to those teams.
Thank you. So maybe to hit right in the center, Ryan, I think several times in your career, first with Codecademy and then with Decrypt, you saw the emergence of new technologies, new trends, and really demand for people that wanted to be educated on how they could participate in technology movements. Based on what you've heard here so far, do you get the itch? Do you have this feeling like there's this building knowledge gap and people really want to understand, how do I become more dangerous with AI? How do I help move my company into being an AI-first organization?
Yeah, I have kind of this general framework that it's been apparent with each hype cycle or new paradigm or whatever we want to call it, be it web developers, then mobile development, then blockchain development, and now let's say the role of the AI engineer. Whenever you post a new job description with a new title and you offer a really attractive salary to it, you're going to get a ton of applicants showing up. But until there's really a core skill set definition behind that title, it's going to be very difficult to, say, build a team or even advance in your own career if you want to break into that particular segment. And so I think it's the industry's responsibility to first define what are the core skills that back that label. And then, of course, you're going to see a bunch of training providers come in and maybe promise quick results. But no matter what the new paradigm is, there's no real substitute for putting in the hard work of learning the foundational concepts. I don't think you can just quickly reskill and then be an expert in any domain. That's certainly not AI engineering. And then there's this, as we get better as practitioners at teaching the skill set, at the same time, companies and startups figure out the right tools to abstract away the really difficult complexities. And so I think inevitably there's this really nice equilibrium that emerges where the practitioners get better at teaching, the tools become easier to use, we come up with the right metaphors or frameworks, and then develop from there. And so once you understand that the answers to those components, it's much easier to hire or to move forward in your own career.
Yeah, I think one of the interesting aspects of this platform shift, if you can call it that, is that the market around cloud has matured. In previous platform shifts, people weren't comfortable outsourcing large parts of their infrastructure or architecture to third-party vendors, but increasingly as the market has matured, people are more comfortable. I'm curious, again, both Fireworks and Modal provide really powerful developer infrastructure, but it is an abstraction layer, and developers don't get to tune everything they may have been able to in the past. Erik or Benny, whoever wants to start, curious like what you're seeing, the challenges or the opportunities with that?
I think we were actually just talking about it off stage. The difficult part is there's a lot of I think there is a bifurcation right now between the AI engineers. There are some that's very sophisticated and there are some that just getting started. And the ones that's very sophisticated want to open up all the possible options that we offer, and even the ones that we don't offer because they know we have the capability. But if we were to offer, we would never be able to take it back. So we do have a hard choice to decide on what features to release, even though we have those features hidden in our platform. I think the other difficulty for offering it as an API is, for better or for worse, the cloud movement is building up, and there are people who's comfortable, but the large institutions are still uncomfortable using us as an API. So then we need to navigate together with them to figure out a way, and I don't think there's an easy way out for that.
Yeah, I think there's maybe two different questions embedded in that question. One that Benny already answered is like more like, if you offer a product, like how do you balance abstraction versus generality? I'm not going to get into that, but I think the second part is like more like on the deployment side. And Benny said, for better or worse, we're moving to the cloud. I think to me, it's for better, like period. Like I don't think there's anything bad. I think, having coded for 30 years and like kind of, I remember when the cloud came, I thought it was like absolutely insane. I was like, why would you ever put your compute in someone else's computer? Like that's absolutely, no one's going to want to use that. But obviously like 15 years later, I think it's safe to say like cloud is here to stay. And I think it's also very, very safe to say that like we're also kind of not just like putting stuff in AWS, we're also to a larger extent putting things in other third parties like Mongo, or like I think Snowflake, I think is kind of a most prime example of this, starting to leverage like more like infrastructure as a service. This is of course like powered also by many other things, like not just sort of the cloud movement itself, but also I think security is very quickly being sort of changing from like network-based to application-based with zero trust, and I think that's very important. So when I started building Modal, like we made a pretty, a strict decision. Like we're only going to be a cloud-hosted multi-tenant service. Like we're going to be a service where you give us the container and we run it for you. And we run it in our own environment. We're not going to, maybe later we'll figure out the VPC peering. And it is correct that like, it is, from the point of view of like cloud security, we're definitely losing some enterprise deals. But I think we're on the right side of history in the sense that like, I think eventually even the enterprise companies will adopt cloud. And not just adopt cloud, they're also going to adopt third-party infrastructure as a service vendors.
I just wanted to qualify that local versus cloud conversation from the perspective as an individual who's trying to learn a new concept. It's phenomenal to have as tight a feedback loop as possible between your environment and yourself, and so I'm a huge proponent of frameworks like MLX, or any way that we can take these tools and run them on our own devices, play with them, and not worry about the fractional cost or waiting for provisioning or what have you. And you just get to play with things without the weight of worrying about, what's my bill going to be at the end of the month. So I think as an individual, when you're playing with a concept, it's really great to be able to open it up locally. And then, of course, once you get to any kind of production deployment, you're going to have many other considerations and requirements.
Okay, so I 100% agree that you need to have very tight feedback loop. I 100% disagree that entails running things locally. I think the real challenge to be solved is how do you make cloud development as fast as local development? And that's what we set out to solve at Modal. And so at Modal, everything runs in the cloud, but we made that as fast as local development. So you can take code and execute it in the cloud with less than a second latency. That to me is the future, right? And that to me also points to the fact that there's a lot of stuff left with the cloud. Like moving to the cloud was, to me, a step backwards in terms of developer experience. Step forward in terms of deployment and scale and many other things. But I think we actually stepped backwards in terms of developer experience. So to me, that is still a big bridge to gap before we fully embrace the cloud for everything.
Andriy, I have to tap you in here. I know you guys have an extremely popular project, GPT-4All, which enables people to run LLMs locally. Maybe talk a little bit about the inspiration for that and why you think, for a software developer, it's important for them to be able to run an LLM locally.
Yeah, sure. So just for a little bit of context, in, I guess, early 2023, the original Llama model came out, and there were a bunch of projects going on that allowed anyone to go in and sort of like start interacting with this like size of model on like local and smaller pieces of hardware. And we kind of built this app called GPT-4All. It's not one of our products that lets anyone go in and run those language models locally. And at the time, we were one of the only ones that allowed you to do that. Since then, you have great tools like Ollama or Faraday or LM Studio, which also allow you to kind of access these capabilities, all backed by a backend called the Llama CPP. And one of the sort of like key insights I think I've learned over the last year when it comes to like sort of like the progression of, let's say, like a new technology, like a large language model, right? There's so many places you could use these things in the world. There's so many places that you can use them that don't have actually high value, but make really cool gimmicky demos. And there's so many places that you can generate insane business outcome from using the technology. And right now, with the technology being so new, nobody knows what's what. Like, nobody has any clue what is going on when it comes to like where this field is going to be in 2 or 3 years when it comes to like the places where LLMs bring the most value. And so what was really cool with building GPT for all and seeing this sort of like this project explode and seeing the adoption of developers being able to access technology is that there are just certain applications in certain domains where you were never able to actually use LLMs up until maybe the last few months from like a remote provider. For example, most of the users of GPT for all are based in Europe and in Germany, where a lot of those companies just would never send an API request to some, North American AI provider. That was just like completely out of the out of the books. And what was really cool seeing there is just being able to enable a larger amount of people to access the technology and see what they can build, and then also grow as they grew, has been just a really interesting kind of experience there.
Super interesting. Matt, maybe coming back to you, one of the things you said at the beginning of the panel was that we would be surprised at how sophisticated large enterprises are, and maybe even in the public sector. A constant theme that we hear was last year was the year of prototypes, this year is the year of production. I'm curious what you're actually seeing. Are people still in prototype phase? Have you actually found customers going to production? And maybe what are the biggest bottlenecks to see more customers go to production?
Yeah, so I think from what we're seeing is that we're definitely still more in the prototype phase, but I think earlier this year we were earlier in the prototype phase where people were just kind of like trying any use case they could think of, see what would stick. And I think through that process, people are actually kind of dialing in on stuff that one is feasible and then two is actually going to be valuable for their business. I think we haven't quite gotten all the way up the curve to these are deployed and driving enterprise value quite yet, but we're getting there. And I think it's really kind of for two reasons. One, as everybody else has alluded to, like we're very early on in defining, like what are best practices for LLM development, that sort of thing. So like even once you find that use case that is going to be good, it takes a lot of experimentation to actually, kind of like get it really dialed in. And again, there's not really a playbook for it yet. And so like what we've been trying to do from our end is try to build tooling in there that will allow for really rapid experimentation. So we're seeing with a lot of the enterprise customers, they're needing to do like a lot of iterations on stuff before they really figure out what works. But we're definitely coming up the curve. Like people are definitely identifying the use cases that are actually going to drive value. And I really do think over the next 6 to 12 months or so, you're going to see a lot of those start to move into more production systems.
Yeah, maybe I can add a little bit more. I do see a lot more production use cases for the past few weeks, specifically because of Llama 3. And that, for me, is very interesting in the sense that many cases already went production in OpenAI was able to easily switch over to Llama 3. And I think that means it's going to be a lot of production use cases this year, but also very competitive market. It's going to be brutal in the next few months, so we'll see.
Very interesting. I think Andriy wanted to.
Yeah, I guess one thing I always like to remind people of like where we were around this time last year, or like a year and 2 months ago. There was one company in the world that you could use to access this technology. And where we are right now, exactly what Ben just said, 1 year later, you basically have a plethora of options from every company imaginable of every sort of like shape and form, and the ones that you can like or you cannot like. And most importantly, those options are as comparable in quality and can be run on your own infrastructure as the thing that was only available through one company last year. And I think that's like one of the craziest things that generative AI has sort of like, that the sort of like blow up of generative AI in the past year has brought us, is this fact that so many people are working towards lowering the cost, lowering the ease of use, and also finding those high value application areas that we can just expect for this kind of like to continue forward. But like I just wanted to emphasize, like it's only been a year since nobody could use this except for through one provider.
All right, there's one more topic I wanted to talk about, which is what is the future life of a software developer? Obviously, I think a lot of people are using Copilot now in their day-to-day. There's some people saying that the start of a new application will start with a prompt in the future. I'll leave it to anybody to opine, but maybe a good starting point actually is, Ryan, knowing what you know about how much AI is going to help with software development in the future, do you still think there's a role for a company like Codecademy, or do we not need to train software developers the way we used to?
I think all content companies are facing a moment of reckoning with Gen AI, but to directly answer your question, I think there's always going to be some kind of training need. I just hope that training and actually performing the skill kind of converge, and so you're constantly learning as you are creating, that you're not necessarily separating the two. But I certainly believe that there's a future for the profession and discipline of software engineering going forward. I'm not one of those people who believe that like AI is going to eradicate the need for software engineers. But I think what's really interesting now, as we're seeing this explosion of product offerings as well as platforms that we as software developers can use, is that it's interesting to see which products are being replaced first. Like I know, just to speak personally, I've stopped using Stack Overflow and Google, and now I use a lot of domain-specific chat AIs or say AI search engines like PHIND, and those are phenomenal, but you still have the same problems. Like you can't just copy and paste code from whatever the output of these models is into your product. You still need to actually understand what's happening, and you need to be able to debug it in the same way that you wouldn't just copy and paste code from Stack Overflow. So, but that's just where it starts, and I certainly don't know where it's going to go.
I mean, just a quick observation is that, I mean, just looking last 40 years or 30 years, something like that, like every decade software engineering gets easier by probably an order of magnitude, and every decade there's 10x more engineers. So I think both of those trends will continue. Like the fact that we make software engineering easier and software engineers more productive actually drives up demand, because now there's suddenly all these software we didn't build in the past that we can build. And so I think demand's going to go up for software. I think we're going to need more software engineers. I think we have an amazing time ahead of us for everyone who wants to be a software engineer.
For those of you, as much as you can opine, at your organizations, are you seeing a meaningful increase in developer productivity that you can attribute back to AI?
Yeah, so I don't get to write as much code as I used to, and then when I do, it's a rough start to like writing that, getting up and running and being able to commit something to production. I was literally sitting with Llama 3 in GPT for All last week writing Terraform code, and it was solving problems for me. So yeah, I feel more productive.
All right, very cool. I guess we have time maybe for one audience question, one or two.
I'm about to run the mic. This is the fun part.
Okay.
Who had it back? Somebody had it. That was.
So with the uncertainty in what AI will look like in the next 3 to 5 years, what skills would you recommend people learn in terms of AI on top of the fundamentals?
Problem decomposition. Can I say that? I feel like a lot of system prompts I see just doesn't make a lot of sense. And deeply understand your product and how to craft that system prompt maybe is the way to go.
I think that effective software engineers that use AI tools are very good architects in a general sense, or if like a film director. You understand, you have a vision for what you want to produce. You're able to understand the pieces or to decompose the problem, as Benny highlighted. And with that vision, I think that's a very important way to approach using these tools, and will continue to be an important way to approach. So that means that you need to study a lot of examples. You need to study a lot of architectures. You need to understand the big picture, or the blueprint. And then the question is, how successfully can we rely on AI models to abstract away the details, or at least do the code generation, and then as software engineers, we're verifying the output.
Thank you. Well, with that, we're at time. I want to take a chance to thank our panelists. Thank you so much. Hopefully this conversation was interesting, and hopefully you guys can catch the panelists if you have any other follow-up questions.